Trigonometry is a branch of mathematics that studies the sides and angles of triangles. For basic trigonometry, you need a right angle triangle. Its sides are called hypotenuse, adjacent, and opposite. The hypotenuse side is always the longest one, but the adjacent, depending on the angle, varies with the opposite. The opposite one is the one that is opposite to the angle you're looking at, and the adjacent is the one that is beside it. Usually there is a memory phrase called SOHCAHTOA, which is used to remember which function to use when doing trigonometry. The sine function is opposite over hypotenuse. So when you use this in the calculator, and depending on which side you are given, then you must multiply or divide the sine function multiplied by the angle with the side that you are given, as shown now. K is the cos function in your calculator, which is adjacent over hypotenuse, and the same rule applies when using K. Depending on which side and angle you are given, then the formula will change. TOA is the tan function in the calculator, which is opposite over the adjacent, and again same rules apply. Depending on which side and angle you were given, the formula will change. A ratio is a very simple concept that compares values. So for example, in an office, there might be 5 men to every 3 women. To write a ratio, you put 5:3, or whichever the numbers are. In the same office, there might be more people, so 10 to every 6 women, which is the same ratio of 5:3. It can also be written as 5:3 or 5/3. A similar shape is a shape that has the same ratio for the corresponding sides and the same angle in their corresponding angles. So for example, these shapes are similar because their ratio is the same and their corresponding angles are the same. This also works with triangles. So for example, these two shapes are similar because they share the same angle and have their corresponding sides are the same. The ratio is 2:1. Check. That means the corresponding sides are the same and their corresponding angles are the same. So that is also a check. This makes them similar shapes. To measure the omega block, we used a set square. A set square has the angles 90, 30, and 60 degrees. So what we did was we measured from the floor to our eyes in the omega block, which was 1.52 meters. Then we moved backwards with the set square with the 60-degree angle of the set square in our eye to see when the 30-degree angle would seem at the top of the building. Then we measured the floor from where we were to the building, and that's how we got our angles. We already knew that there was a 60-degree angle, and from where we were standing to the building there was 9.4 meters. And since the angle was 60, we just had to use the tan function in our calculators to do basic trigonometry and get the length of mega block. The answer we got was 16.28 plus the 1.52 meters that we didn't add with our height. It gave us 17.80. To verify our method, we measured 4 bricks, which were 25 centimeters. Then we counted the amount of bricks in the building, which were 260. The method that we used that was most accurate was the set square method, not the brick method. It gave us a more precise answer, which seemed more believable. The problem with the brick method was that in between each brick there was a little piece of cement, which gave a margin error that was really large. The marginal error was of 1.55 meters, and that is a lot. This is a believable answer because if we divided 17.8 by 4, it would give us 4.45, and that would be the height of each of the floors of the omega, and this seems really believable. In real life, trigonometry is used for many things, like measuring mountains, buildings, and making sure control towers are at exact heights that they have to be. A concrete example of when trigonometry is used, it would be in a control tower with a marine. They will have to use trigonometry to see how far away boats are from the coast. So they will use an angle of depression and use basic trigonometry to find how far away a boat is.